Now let us consider a strong acid and a strong base reaction. So we have HCl, that is a strong acid, and we have NaOH, that is a strong base, and when they react they form NaCl and water. NaCl is the salt, and we will also have water. This kind of equation in which we write molecules is called molecular equation. So it is the equation in which reacting species is written as molecules. So for the above reaction, this is the molecular equation. We can also write Ionic equation. Now it is the equation in which reacting species is written as ions. For example, for the above molecular equation, we can write HCl as H plus Cl minus, NaOH we can write Na plus OH minus, and this we are writing because HCl is a strong electrolyte. This means it will 100% dissociate into the solution. Similarly, NaOH is a strong electrolyte. Now we have NaCl. This is also a strong electrolyte. So we can write Na plus Cl minus. But for water, we cannot write dissociated ions because H2O is weak electrolyte. So generally, whenever we have ionic bond, those are a strong electrolyte. In case of covalent bonds, we will have weak electrolyte. So this is the Ionic equation. Similarly, we can define something called net Ionic equation. It is the equation in which only the reacting ions is written. For example, if I see the above equation, so this is the Ionic equation. Now you see, we have Na plus left side and we also have right side. Similarly, Cl minus, we have both sides. So we can cancel and we will have simply H plus plus OH minus H2O. This is the net ionic equation or overall ionic equation. So this is net ionic equation. Basically in this reaction, Cl minus ion and Na plus ion is not participating. These kind of ions are called as spectator ions. So in this reaction, we have Na plus and Cl minus as a spectator ions. So for the above reaction, that is a strong acid, a strong base, this is the net ionic equation. Let us consider another a strong acid, a strong base reaction. Let us say we have HNO3 and this is reacting with KOH. Both are strong, so this is a strong acid and this one is a strong base. It will form salt, that is KNO3 plus water. So this is molecular equation. Now let us write ionic equation. Since this is a strong electrolyte, we can write H plus plus NO3 minus, and this is also a strong electrolyte, we can write K plus OH minus. KNO3 is a strong electrolyte, K plus plus NO3 minus, and H2O is a weak electrolyte, so we cannot ionize H2O. This is ionic equation. Now we can also write net ionic equation, that is simply we have to cancel out the spectator ions. So NO3 minus is a spectator ion and K plus is a spectator ion. So this is the net ionic equation. H plus plus OH minus, that gives H2O. This is net ionic equation. Now one important point we have, whenever we have a strong acid and a strong base reaction, net ionic equation is same. You see in this case we have H plus plus OH minus H2O, that is 1 mole H2O formation. You see in this reaction again we have net ionic equation is same. So we can say whenever we have a strong acid and a strong base reaction, net ionic equation or overall ionic equation is same, that is H plus plus OH minus is H2O, or we can say formation of 1 mole of water. Now we define heat of neutralization, that is the energy released when 1 mole of H plus reacts with 1 mole of OH minus and it gives 1 mole of H2O. So we can define heat of neutralization. And it is defined as when 1 mole of H plus reacts with 1 mole of OH minus the energy released is defined as heat of neutralization. So whenever we have a strong acid or strong base reaction, energy released is same because net ionic equation is same. You see what is happening in this reaction. Basically, we are forming one oxygen hydrogen bond. So energy released is same, and this is called delta H, neutralization. So heat of neutralization, energy released is same because in all cases we are forming 1 mole of oxygen hydrogen bond. Energy released is same in all cases because we are forming 1 mole of oxygen hydrogen bond. And from experiment this value is measured and this comes out to be 57.3 kilojoule per mole. So we can write H plus OH minus H2O delta H neutralization. This is equals to minus 57.3 kilojoule per mole. Minus sign says energy is released in this process. Energy is released. And this is because there is a bond formation. So whenever we have bond formation, energy will be released. Now let us say if I ask a question here, what will be the energy released in this process? Now see in this equation, this is again a strong acid, a strong base reaction. So we have a strong acid and we have a strong base and we have salt plus water. Now if you see this reaction, basically we have formed 2 mole of water. When we form 1 mole of water, we have 57.3 kilojoule energy released. So in this process, energy released is equals to 2 times 57.3 kilojoule. And this is the energy released. So we can put a negative sign. So this energy is released. So this is the heat of neutralization. When 1 mole of H plus reacts with 1 mole of OH minus, the energy released in this process is defined as heat of neutralization. Heat of neutralization can also be defined in terms of gram equivalent. So in that case we say when 1 gram equivalent of acid, when 1 gram equivalent of acid, and this is a strong, reacts with 1 gram equivalents of base, and this is a strong, energy released in this process, or we can say enthalpy change, energy released or enthalpy change in this process is called heat of neutralization. So in this lecture we discussed about heat of neutralization. In some other lecture we will discuss about heat released when weak acid reacts with a strong base or weak base reacts with a strong base.